In this video, we look at our coordinate systems in 3-space further. Today now we'll look at circles. In 2 dimensions, the formula or equation for a circle is x minus h squared plus y minus k squared equals r squared, where the center is at hk and we have a radius r. In 3-space, all we're doing is shifting that up a little bit larger. We're adding in the z minus z naught squared. Rather than using h and k and coming up with a 3rd letter, we're just going to go with x naught, y naught, and z naught as the center of our sphere now. It's no longer a circle, it's a sphere. And the radius is again going from that center origin anywhere to on the circle. So if this is coming to right here on the circle, that is a radius r. When we have the spherical coordinates, we'll use a different letter for r, but that's what we've got for now. Another form of that equation is x squared plus y squared plus z squared. If the center, if we multiply or multiply all this stuff out and gather like terms, we'll have x squared plus y squared plus z squared plus a gx, an hy, and an iz plus some constant equals 0. And this can lead to 3 different forms of that equation. One of them will generate a sphere. One of them is a single point. And the final outcome is nothing. There's no graphical representation in real coordinate system. When we start lectures, we'll discuss in person how to go about like easily setting up this graph, the XYZ coordinate. You can see how I've done it here though. I did Y and Z just like I do X, and then I do come out at a diagonal to show out of the page. Sometimes I show the full lines going downward and left, and then a dotted line to show into the page. Sometimes if I'm just focusing on a particular small piece, I'll do this where it's a little less lines on the screen. In this same set, let's look at some examples. Our first example, I've got x squared plus y squared plus z squared plus 10x minus 4y plus 6z minus 11 equals 0. There's a lot going on there. So what I've done is I've grouped together the variables. I've grouped 10x with x squared, and I've done completing the square, which is taking half the coefficient of the x to the first power, 10 divided by 2 is 5, and squaring it, and adding that to both sides, 25 here, 25 here. I did that the same for each of them. I put the negative 4y with y squared. We cut negative 4 in half and square it is negative 2 squared is 4, add 4 to both sides. And the same thing with z, half of 6 is 3, 3 squared is 9, add 9 to both sides. I've also taken the liberty of moving the 11 to the other side by just doing a quick plus 11. When I add up all the constants on the right, I get 49. On the left, I've done the completing of the square, which is you just take half that value. That's the point of completing the square, so that we can write it like this. X plus 5 squared, y minus 2 squared, and z plus 3 squared equals 49. This is where there's a lot of algebra in this class. Hopefully you guys are up on your game. If not, I do have other videos for algebra that you can refresh on in my YouTube channel. They are not short little bite-sized ones like this. This does generate a circle, or a sphere, sorry, a sphere. The radius is the square root of the right side is 7. And the coordinates are the opposite of the signs on the inside, negative 5, positive 2, and negative 3. Okay. So that's an outcome where this equation generates a sphere. If the right side, when we were done, equaled 0, then we have a radius of 0, and which means we have a point there, but we're not going outward from it. So if we're not going outward from it, we just have a single point. And obviously the last one scenario would be where the right side is negative. The left side is a bunch of squared terms, and squared terms are non-negative. They're positive values, so the sum of them should be positive or non-negative. They could all be zero, but zero or a positive number never equals a negative number. So we have no solution. And I will have another video for the next section.